What's up YouTube, and welcome to episode 106 of the Chaos Daily. Let's get into it. Today's episode is really late, and I'm very sorry. I have been running CFD simulations all day, so the computer has been occupied. But yeah, let's get into it. We've got a lot to cover. So first off, the print that I got going for the second part of the EDF mount, it failed quite spectacularly. It was only held on the build plate over here somewhere. All of this collapsed. Yeah, no good. Most of the front edge looks pretty good though, but the rest of it is just pancaked. So, but it's a good thing that that failed because I don't think there was enough resin in there to finish the job anyways. Plus, through running my CFDs, I noticed a couple of things I wanted to change. Additionally, when I start running CFDs, the first thing I look at are drag properties, and I look at pressure distribution over the surface of the wings and stuff to see if, I've got good lift fall off to the wingtip, so I'm not producing too much lift on the wing, and all those sort of things. Just really baseline overall things that I look at. First things I started to notice was the drag was really low. The drag was really low, coming at a 0.2 coefficient of drag. Like it's super low, like glider territory, and that's even with the EDF pod on the back, which I found was just staggering. The fact with the EDF pod, without the EDF doing like the fan simulation and everything, like just dead pod, like it's just drag, it's extra drag. It was still coming in at really low numbers, so I was just super pleased with that. But one of the things I noticed was that the lift ratio was too low, so I then went back into the CAD and I adjusted the chord, made it a bit thicker, and changed the front profile of the chord so that it would where the chord line is, and how it change how the front shape of the aircraft is, where it will preferentiate airflow over the top or under the bottom, where it meets there at that point. By adjusting those parameters, you can adjust how much additional airflow you catch from that very leading edge, how much of it will want to go up and how much of it will want to go down. And the more you go up, the greater your lift ratio is going to be. The more you go down, the lower your lift ratio is going to be. But getting it to go one way or the other also changes your drag properties. You start developing parasitic drag underneath the wing surface and stuff like that. So getting it just balanced just right is a bit of an art form, but yeah. So I made a couple of those changes in the CAD, which means that part that I printed would not match with the rest of the fuselage. So it's a good thing that failed anyways, so I can update the STL files. After that, then I can start looking at the more nitty-gritty details, going in and looking at the numbers. I start looking at the flow patterns over the wing, looking at the wingtip vortex shedding to see what kind of parasitic drag that I'm building on the trailing edge of the wing all the way out to the tip. This one is beautiful. The wingtip that I've created on this, the vortex that is shed off the wingtip is tight. It's really tight. It's oh my god. And also with the way that the pressure differential and the lift characteristics from the root through to the wing, the fall off of the lift characteristic is really nice. It's a really nice good taper. It's not quite the same as how Prandtl works, where they have an S curve on the ratio, but it's more of like, the way I do it is I look at the pressure distribution of the wing, like the actual color gradient, and I look at how it falls off, how it tapers, and that and how it's positioned on the wing. Is it towards the leading edge or the trailing edge? What those ratios are, and it's sort of like a trial and error thing that I've built up over the years. But by looking at that, I can then develop my own sort of, not quite an S curve. It's more of a fall off, more of like a parabolic fall off, and then it S curves out the end. So it's not quite the same, but it does give me more control over where I put the lift for the structure when I go to design the wing structure later, where I'm putting ailerons and stuff. It gives you more control, rather than, this is one of the traps that aerodynamicists fall into when they design wings. They design the wing and they go, okay, here's the lift characteristic. We want the lift to fall off towards the end by this much and such. But they do all of these calculations, all these simulations, in a vacuum, sort of detached from the next stage of development, which is your internal structure, which is your mechanisms, your ailerons, your control surfaces, all of those sort of things. So I try and think ahead about what I'm going to do with those things when I'm looking at these properties of the aerodynamics and go, okay, I want to do it this way. I want it to have these characteristics now. So when I design those things and those aspects, they sort of complement each other rather than fighting with each other later on down the road. After going through all that, super happy with that. And then I start looking at things like flow characteristics around the EDF. You can see here, I'm specifically looking at the boundary layer interaction of the top surface of the fuselage to where the nacelle starts. I want to see how much of that low pressure zone and those vortex and the velocity index of the airflow in those areas, how that's interacting. I'm not creating too much suction at the bottom there with the boundary layer, and that the boundary layer where it is sucking air in for the bottom edge of the nacelle is pushing forward and not around the lip of the nacelle, which is good, which means that when I get steady state flow over the wing, I'm getting a good pickup from that, and it's not causing a very large amount of low negative pressure on that bottom edge of the nacelle. It's getting pushed out forward and spread out over the fuselage, which is what you want. It's really good. You get far less boundary layer detachment, you get far less drag and parasitic drag from the interaction of the airflow around those areas where you're getting those low pressure zones of the air intake for the EDF. So I'm super happy with that. I'm happy with the design. I hope you guys don't mind the episode being so late. But we'll leave it there for today's episode. Make sure you hit the like button. Make sure you subscribe if you're not. As always, I'm Chaos. And until next time, expect the unexpected. And I'll see you guys later.
And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.